Intro to Webpack. Once we start working in production with React, there are a lot of questions to pose. Either how do we want to deal with JSX and S6 transformation? How can we manage our dependencies? How can we optimize our images and CSS? Many different tools have emerged to answer these questions, including Browserify, Dunk, and Grunt. Due to its features and widespread adoption by large companies, Webpack has also emerged as one of the leading tools for bundling CommonJS mod. Let's see Chapter 2 for more on CommonJS. Webpack is built as a module bundler. A module bundler takes all of our different files JavaScript, LESS, CSS, JSX, S6, and so on and turns them into a single file. The two main benefits of modular bundling are modularity and network performance. Modularity will allow you to break down your source code into parts, or modules, that are easier to work with, especially in a team environment. Network performance is gained by only needing to load one dependency in the browser, the bundle. Each script type makes an HTTP request, and there is a latency penalty for each HTTP request. Bundling all of the dependencies into a single file allows you to load everything with one HTTP request, thereby avoiding additional latency. Aside from transforming, Webpack also can handle code splitting. Splits up your code into different chunks that can be loaded when you need them. Sometimes these are called roll-ups or names. The aim is to break up code as needed for different pages or devices. Minification removes whitespace, line breaks, lengthy variable names, and unnecessary code to reduce the file size. Feature flagging sends code to one or more but not all environments when testing out features. Hot module replacement HMR. Watches for changes in source code. Changes only the updated modules immediately. Webpack loaders. A loader is a function that handles the transformations that we want to put our code through during the build process. If our application uses S6, JSX, CoffeeScript, and other languages that can be written natively by the browser, we'll specify the necessary loaders in the webpack.config.js file to do the work of converting the code into syntax that can be written natively by the browser. Webpack has a huge number of loaders that fall into a few categories. The most common use case for loaders is transferring from one dialect to another. For example, S6 and React code is transpiled by including the Babel loader. We specify the types of files that Babel should be run on, then Webpack takes care of the rest. Another popular category of loaders is for styling. The CSS loader looks for files with the .scss extension and compiles them to CSS. The CSS loader can be used to include CSS modules in your bundle. All CSS is bundled with JavaScript and automated. How we add it when the bundled JavaScript file is included. There's no need to use link elements to include style sheets. Check out the full list of loaders if you'd like to see all of the different options. Recipes. After the Webpack build, the recipes that we built earlier in this chapter has some limitations that Webpack will help us alleviate. Using a tool like Webpack to statically build your client JavaScript makes it possible for teams to work together on large-scale web applications. We can also gain the following benefits by incorporating the Webpack module bundler. Modularity using the common JS module pattern in order to export modules that will later be imported or required by another part of the application makes our source code more approachable. It allows development teams to easily work together by allowing them to create and work with separate files that will be statically binned into a single file before sending to production. Composing with modules, we can build small, simple, reusable React components that we can compose efficiently into applications. Smaller components are easier to comprehend, test, and reuse. They are also easier to replace down the line when enhancing your applications. Speed packaging all of the application's modules and dependencies into a single client bundle will reduce the load time of your application because there is latency associated with each HTTP request. Packaging everything together in a single file means that the client will only need to make a single request. Minifying the code in the bundle will improve load time as well. Consistency since Webpack will transpile JSX into React and S6 or even S7 into Universal JavaScript, we can start using tomorrow's JavaScript syntax today. Babel supports a wide range of ES-Next syntax, which means we do not have to worry about whether the browser supports our code. It allows developers to consistently use cutting-edge JavaScript syntax. Breaking components into modules approaching the recipes that with the ability to use Webpack and Babel allows us to break our code down into modules that use S6 syntax. Let's take a look at our state. Less functional component for recipes example 5 to 13. Example 5 to 13. Current recipe component. Const recipe equals name, ingredients, steps equals ID equals baked salmon. Name equals ingredients. Ingredients.map ingredient, I equals ingredient. Dot name. Class name equals instructions. Cooking instructions. Steps.map step, I equals step. This component is doing quite a bit. We are displaying the name of the recipe, constructing an unordered list of ingredients, and displaying the instructions, with each step getting its own paragraph element. A more functional approach to the recipe component would be to break it up into smaller, more focused stateless functional components and compose them together. We can start by pulling the instructions out into their own stateless functional component and creating a module in a separate file that we can use for any set of instructions. Example 5 to 14. Example 5 to 14. I. Instructions component. Const instructions equals title, steps equals class name equals instructions. Title. Steps.maps, I equals S. Export default instructions. Here we have created a new component called instructions. W. E will pass the title of the instructions and the steps to this component. T. His way we can reuse this component for cooking instructions, baking instructions, prep instructions, or a pre-cooked checklist on anything that has steps. Now think about the ingredients. In the recipe component, we are only displaying the ingredient names, but each ingredient in the data for the recipe has an amount and measurement as well. W. E could create a stateless functional component to represent Set a single ingredient. Example 5 to 15. Example 5 to 15. I. Ingredient component. Const ingredient equals amount, measurement, name equals amount, equals measurement, equals name. Export default ingredient. Here we assume each ingredient has an amount, a measurement, and a name. We destructure those values from our props object and display them each in independent class span elements. Using the ingredient component, we can construct an ingredients list component that can be used anytime we need to display a list of ingredients. Example 5 to 16. Example 5 to 16. I. Ingredients list using ingredient component. Import ingredient from /ingredient. Const ingredients list equals ingredients. List.make ingredient, I equals. Key equals I, ingredient /. Export default ingredients list. In this file, we first import the ingredient component because we are going to use it for each ingredient. T. Key ingredients are passed to this component as an array in a property called list. Each ingredient in the list array will be mapped to the ingredient component. The JSX spread operator is used to pass all of the data to the ingredient component as props. Using spread operator, ingredient / is another way of expressing amount equals ingredient.amount. Measurement equals ingredient.measurement. Name equals ingredient.name /. So, given an ingredient with these fields, net ingredient equals amount 1, measurement cup, name sugar. We get amount equals 1, measurement equals cup, name equals sugar /. Now that we have components for ingredients and instructions, we can compose rec. Items using these components. Example 5 to 17. Example 5 to 17. If active recipe component. Import ingredients list from /ingredients list. Import instructions from /instructions. Const recipe equals name, ingredients, steps equals ID equals name lowercase replace /g dash name. List equals ingredients / title equals cooking instructions. Steps equals steps /. Export default recipe. First we import the components that we are going to use, ingredients list and instructions. N. And we can use them to create the recipe component. Instead of a bunch of complicated code building out the entire recipe in one place. We have expressed our recipe more declaratively by composing smaller components. N. Not only is the code nice and simple, but it also reads well. T. This shows us that a recipe should display the name of the recipe, a list of ingredients, and some cooking instructions. We've abstracted away what it means to display ingredients and instructions into smaller, simple components. In a modular approach with CommonJS, the menu component would look pretty sim. T. The key difference is that it would live in its own file, import the modules that it needs to use, and export itself. Example 5 to 18. Example 5 to 18. C. Completed menu component. Import recipe from /recipe. Const menu equals recipes equals. Delicious recipes equals recipes. Recipes.macrotype I equals. Key equals up recipe /. Export default menu. We still need to use React DOM to render the menu component. We will still have an index.js file, but it will look much different. Example 5 to 19. Example 5 to 19. C. Completed index.js file. Import React from React. Import render from React DOM. Import menu from /components/menu. Import data from /data/recipes. Window.react equals React. Render equals data /document.getElement read React container. The first four statements import the necessary modules for our app to work. Instead of loading React and React DOM via the script tag, we import them so Webpack can add them to our bundle. We also need the menu component, and a sample data array which has been moved to a separate module. It still contains two recipes: baked salmon and fish tacos. All of our imported variables are local to the index.js file. Setting window.react to React exposes the React library globally in the browser. His way all calls to React.createElement are assured to work. When we render the menu component, we pass the array of recipe data to this compo. Int as a property. His single React DOM.render call will mount and render our menu component. Now that we have pulled our code apart into separate modules and files, let's create a static build process with Webpack that will put everything back together into a single file. Installing Webpack dependencies. In order to create a static build process with Webpack, we'll need to install a few things. Everything that we need can be installed with npm First, we might as well install Webpack globally so we can use the Webpack command anywhere. Sudo npm install gwebpack. Webpack is also going to work with Babel to transpile our code from JSX and S6 to JavaScript that runs in the browser. We are going to use a few loaders along with a few presets to accomplish this task. npm install Babel core, Babel loader, Babel preset end, Babel preset React, Babel preset stage 0 save dev. Our application uses React and React DOM. We've been loading these dependencies with the script tag. Now we are going to let Webpack add them to our bundle. We'll need to install the dependencies for React and React DOM locally. npm install React DOM save. This adds the necessary scripts for React and React DOM to the /loader modules folder. Now we have everything needed to set up a static build process with Webpack. Webpack configuration for this modular recipes app to work. We are going to need to tell Webpack how to bundle our source code into a single file. We can do this with configuration files, and the default Webpack configuration file is always webpack.config.js. The starting file for our recipes app is index.js. It imports React DOM, and the menu.js file. This is what we want to run in the browser first. Wherever Webpack finds an import statement, it will find the associated module in the file system and include it in the bundle. Index.js imports menu.js. Menu.js imports recipe.js. Recipe.js imports instructions.js and ingredients list.js. And ingredients list.js imports ingredient. End.js. Webpack will follow this import tree and include all of these necessary modules in our bundle. S6 import statements. We are using S6 import statements, which are not presently supported by most browsers or by Node.js. The reason S6 import statements work is because Babel will convert them into require module /path statements in our final code. The require function is how common JS modules are typically loaded. As Webpack builds our bundle, we need to tell Webpack to transpile JSX to pure React elements. We also need to convert any S6 syntax to S5 syntax. Our build process will initially have 3 steps: Figure 5 to 4. Figure 5 to 4. Recipe app build process. The webpack.config.js file is just another module that exports a JavaScript literal object that describes the actions that Webpack should take. His file example 5 to 20 should be saved to the root folder of the project, right next to the index.js file. Example 5 to 20. Black.config.js module.exports equals entry./src/index.js output path dist/assets file name bundle.js module rules test/.js/ exclude /loader modules /loader Babel loader query presets env stage 0 React. First, we tell Webpack that our client entry file is ./src/index.js. It will automatically build the dependency tree based upon import statements starting in that file. Next, we specify that we want to output a bundle JavaScript file to ./dist/assets/bundle.js. This is where Webpack will place the final packaged JavaScript. The next set of instructions for Webpack consists of a list of loaders to run on specified modules. rules field is an array because there are many types of loaders that you can incorporate with Webpack. In this example, we are only incorporating Babel. Each loader is a JavaScript object. The test field is a regular expression that matches the file path of each module that the loader should operate on. In this case, we are running the Babel loader on all imported JavaScript files except those found in the loader modules folder. When the Babel loader runs, it will use presets for S2015. S6 and React to transpile any S6 or JSX syntax into JavaScript that will run in most browsers. Webpack is run statically. Typically, bundles are created before the app is deployed to the server. Since you have installed Webpack globally, you can run it from the command line. Webpack time 1727 ms asset size chunk names bundle.js 693 KB 0 emitted main 169 hidden modules. Webpack will either succeed and create a bundle, or fail and show you an error. Most errors have to do with broken import references. When debugging Webpack errors, look closely at the file names and file paths used in import statements. Loading the bundle. We have a bundle, so now what? We exported the bundle to the dist folder. This folder contains the files that we want to run on the web server. The dist folder is where the index.html file example 5 to 21 should be placed. This file needs to include a target development where the React menu component will be mounted. It also requires a single script tag that will load our bundled JavaScript. Example 5 to 21. Index.html. Charset equals at 8. React Recipes app. ID equals React container. src equals assets/bundle.js. This is the home page for your app. T will load everything it needs from one file, one HTTP request bundle.js. You will need to deploy these files to your web server or build a web server application that will serve these files with something like Node.js or Ruby on Rails. Source mapping. Bundling our code into a single file can cause some setbacks when it comes time to debug the application in the browser. We can eliminate this problem by providing a source map. A source map is a file that maps a bundle to the original source files. With Webpack, all we have to do is add a couple of lines to our webpack.config.js file. Example 5 to 22. Example 5 to 22. W. webpack.config.js with source mapping. Module.exports equals entry./src/index.js, output. Path dist/assets, file name bundle.js, source map file name bundle.map. DevTools source map, module. Rules. test/.js/ exclude/loader modules/ loader Babel loader, query. Presets env, stage 0, React. Setting the DevTool property to source map tells Webpack that you want to use source mapping. A source map file name is required. It is always a good idea to name your source map file after the target dependency. W. Webpack will associate the bundle with the source map during the export. The next time you run Webpack, you will see that two output files are generated and added to the assets folder, the original bundle.js and bundle.map. The source map is going to let us debug using our original source files. In the Sources tab of your browser's developer tools, you should find a folder named webpack // Inside of this folder, you will see all of the source files in your bundle figure 5 to 5. Figure 5 to 5. Sources panel of Chrome developer tools. You can debug from these files using the browser's step-through debugger. C. Clicking on any line number adds a breakpoint. Refreshing the browser will cause JavaScript processing when any breakpoints are reached in your source file. Y. O. You can inspect scoped variables in the scope panel or add variables to watch in the watch panel. Optimizing the bundle. The output bundle file is still simply a text file, so reducing the amount of text in this file will reduce the file size and cause it to load faster over HTTP. Things that can be done to reduce the file size include removing all whitespace, reducing variable names to a single character, and removing any lines of code that the interpreter will never reach. Reducing the size of your JavaScript file with these tricks is referred to as minifying or uglifying your code. Webpack has a built-in plugin that you can use to uglify the bundle. In order to use it, you will need to install Webpack locally. npm install Webpack save dev. We can add extra steps to the build process using Webpack plugins. In this example, we are going to add a step to our build process to uglify our output bundle, which will significantly reduce the file size. Example 5 to 23. Example 5 to 23. W. Webpack.config.js with uglify plugin. var webpack equals require webpack. Module.exports equals entry.src/index.js, output. Path dist/assets, file name bundle.js, source map file name bundle.map. DevTools source map, module. Rules. test/.js/ exclude/loader modules/ loader Babel loader, query. Presets env, stage 0, React. Plugins. New webpack.optimize.uglify.js plugin. Source map true, warnings false, mangle true. To use the uglify plugin, we need to require Webpack, which is why we needed to install Webpack locally. Uglify.js plugin is a function that gets instructions from its arguments. Of nce we uglify our code, it will become unrecognizable. We are going to need a source map, which is why source map is set to true. Setting warnings to false will remove any console warnings from the exported bundle. Angling our code means that we are going to reduce long variable names like recipes or ingredients to a single letter. The next time you run Webpack, you will see that the size of your bundled output file has been significantly reduced, and it's no longer recognizable. Including a source map will still allow you to debug from your original source even though your bundle has been minified. Bundling CSS. Another nice feature of Webpack